Hello everyone and welcome to our course on artificial intelligence and its application. So this course will be delivered by me, that is Aditya SK, the Chief Technology Officer of TechWid Labs. So before moving on to the entire course or curriculum, so we'll just go through a few introduction slides and then we'll move on to the whole topic of artificial intelligence and its applications. So about the speaker, so I am Aditya SK. I'm the Chief Technological Officer of TechWid Labs. So I've been a consultant for artificial intelligence and machine learning based applications in companies like Bosch as well as companies like TVS also. So I work on technologies like AI, computer vision based machine learning, as well as technologies like blockchain and IoT. So this is my forte. So let us move to the course content. So we'll discuss what we'll be doing in this whole course of artificial intelligence. So before moving on to the course, one thing we would like to discuss here is the general instruction or the guideline. So what is the general instruction or the guideline that the students all need to pay attention to while listening to this course or while attending this course? So the first and foremost thing that I would like to tell is students are requested to they're requested to pay close attention to the webinar lecture and avoid missing them. So it's all the webinars or all the courses or all the parts of the videos are interrelated to each other. So please do avoid missing them. So each one of them will have a huge knowledge base. So that is very important. So you need to always pay attention to each and every webinar and never miss them. So don't skip them and move on to the next one. So that will cause you to not able to understand many of things. So very important thing is please don't miss any of these webinar series. So watch each and every webinar on a whole scale. Don't skip them and watch it. So it will cause more and more confusions. So next thing is students are requested to make notes on the key points in the webinar. So students are always requested to make notes. So making notes will make your work easier. So it will be like a revision, as well as you can stress upon the main points which you have listened to in this course, and you can work on them for more and more info as well as to get a clear picture. So we request you to make notes on the key points in the webinar. So that is also very important. And students are also requested to not execute any programs while the webinar is being conducted. So students are now requested not to execute any that is the software or hardware installation procedures, or run the code or try to type along with me when this course is happening. So what that will do is it will distract you and it will prevent you from getting a good understanding of the whole subject. So that is a huge problem. So make sure that you are listening to me on the entire course duration and not typing or not installing any software. So that will cause you not to understand many things. So very important, that is one thing. So doubts and clarifications will be answered at the end of the session. So all the doubts and clarifications will be answered after the session. So if you have any doubts, it will be answered through chat. So if not chats, or if chats are not available, you can take in the email ID and you can mail it to my email ID. So I'll be answering each and every doubt that you ask. So these things are the general guidelines and instructions for all the students who are willing to do this course. So very important things. So please do follow them. That will help you a lot in this particular course. So moving on, before going into the depth of the subject, or before understanding what is artificial intelligence and each and everything, what we'll be trying to do is how you should select a particular technology. So that is very important. So whenever you come into a conclusion that I am learning this particular technology or I am into this particular technology, what you will do is you will just move with the flow, or you will just hear from people that this has demand, that technology has demand, this technology I need to choose and work on. So how actually you are trying to choose a technology is very important, and that is why we have we are discussing the topic called as hype cycle. So for each and every technology, so there is a cycle called as hype cycle for each and every technology. So what is hype cycle or what is Gartner cycle is very important to understand. So Gartner is an American business analyst as well as a technology analyst who analyzes the technology hype. So when the technology is growing, when the technology is falling, and what is the time duration that the technology will exist. So that is very important whenever you're learning some technology. So since I'm catering to like undergraduate or postgraduate students. So most of the people would be trying to get into new technologies or make these technologies a part of their career. So you're willing to pursue your entire life on this particular technology. So very important to choose the technology before like going into the depth of it. So basically, to understand which technology to choose, so what you need to do is you need to like look into the hype cycle. So Gartner has created a hype cycle for emerging technology. So considering the applications of artificial intelligence and artificial intelligence into picture, so this entire graph which is telling us this is the hype cycle where all the technologies that are now in hype. So many of the technologies that are related to your artificial intelligence as well as applications of artificial intelligence are in the hype cycle. So each and every technology, consider any web development, Android application development, each and every technology has a growth stage. So growth stage or like birth stage, when it is triggered and the birth of the technology falls into the picture, then people will start learning it. So when people start learning it, so that is like a growth career of the whole technology. After learning the whole technology, the main issue is how applications are built using the particular technology. Since mobile phones came into existence, Android application development, the demand for Android application development increased. So similarly, how the technology will grow into the particular hype stage and then it will fall, leading to new and new technology. So that is the whole concept of Gartner's hype cycle. So some technologies might live for long durations, that is, it may stay for 20 to 30 years, and some technologies will just stay for 5 years, 2 years or 1 year. So that is how technologies are classified, and that is why you need to choose a particular technology which is either in growth stage or it is in hype stage. So if you start learning, that is, how to build a microcontroller or how to build a microprocessor, obviously they have built it in 1980s and you don't need to do that again. So that is like an outdated technology that you're trying to learn. But considering that you are chosen to learn artificial intelligence, which is one of the most trending domains, or the domains in which it is in the hype cycle and its applications are in the hype cycle, so it is the best time to start learning artificial intelligence and its applications as well. So this will be like a good environment or a good time to start learning artificial intelligence as well as its applications. So yeah, so this is about Gartner's hype cycle for emerging technologies. So then what will be the common questions that will be answered in this session? So very important to understand. So there are some quite a lot of questions which needs to be understood, and quite a lot of things needs to be understood while learning some technologies. So many of the people have a lot of confusion regarding which technology should I learn and what are these technologies and general definition. So whenever you hear a term called artificial intelligence, the main problem is you don't know what is artificial intelligence, what is machine learning. You've just heard the buzzwords from many people. So what are the common questions that will be answered in this session are, what is artificial intelligence? So we need to learn that. What is artificial intelligence? What is machine learning? Is artificial intelligence another name for machine learning? So is there any difference between artificial intelligence or machine learning, or is it equal to machine learning? So that is there. What is deep learning? What is so deep about deep learning? So is there any relationship between your machine learning, artificial intelligence as well as deep learning? So what can we create using artificial intelligence? So that is the next question. So you have learned artificial intelligence, you know that the technology is booming, but what is the actual thing that is being created by using artificial intelligence is another thing that we need to understand. So these are all the important the questions that will be answered during this session. So once we complete this session, your mind should be very clear and able to make distinguished differentiations between the different terminologies that we learn, and also able to answer all these questions which we would which we have discussed right now. So this is an important questionnaire which needs to be answered. A person who is starting with this course needs to answer these questions with absolute no confusion. So everything must be clear if a person has learned the technology very well. So these are all the basic things that needs to be answered properly while learning the technology. Okay. So the next part that is coming into picture is what is intelligence. So the major thing is people tend to move about artificial intelligence but fail to understand the basic thing that is intelligence. So what is intelligence, or like how do you define intelligence, or how intelligence is defined in terms of personalities? If you're taking in people, so how do you call a person as intelligent person, or what kind of a person is an intelligent person is the thing that we need to answer now. So firstly, what we'll try to do is we'll take in two situations, or we'll take in two people. One is Lisa and one is Harry, and they are asked to do a particular task. So that is the thing that we need to answer now. So Lisa and Harry needs to do a particular task. So how do we tell that whether Lisa is intelligent or Harry is intelligent is the thing that we need to analyze now. So first and foremost, if any of these two people perform the task that is given more efficiently, if they complete the task with more efficiency, so that is one thing. So then in a quick span of time, if they do the given amount of work in a quick span of time, that is, if they're doing the work in a more faster pace, so that is they're utilizing the knowledge gained from the previous task. So if they're given the previous task similar to this task, and they're able to utilize the knowledge that they have gained from completing the previous task in this particular task, then it is a sign of intelligence. So then if they can adapt to the new challenges, so what are all the new challenges that the people can adapt to? So that new challenges is also a part of intelligence. So while defining the term called intelligence, so they need to call a person to be intelligent, so they must do these particular things. So that is nothing but they must be more efficient. They must do a particular thing in a quicker amount of time. They should use the knowledge from their previous tasks to complete the particular task and adapt to new challenges. So whenever they are given with new situations, they must be able to adapt to the new challenges. So that is how you can call a person as more intelligent person. So intelligence is defined as like nothing but whoever can do a given bit of task more efficiently than the other person. So that is how you call the term called intelligence. So that is how intelligence is defined. So actual definition of intelligence is nothing but the capacity, or the defined as capacity for logic, understanding, self-awareness, learning, reasoning, planning, creativity, critical thinking, and problem solving. So what is this logic? So applying logic in the particular problem solving skill. Understanding what is the problem. Self-awareness is nothing but making yourself aware of the entire surroundings and the entire problem. Learning is nothing but from the previous experiences, if you can learn something. Reasoning is why so and so things are happening, or how to solve those things. Planning is nothing but foresight. Whatever you need to do, you need to plan. Creativity is using your own imagination. Critical thinking and problem solving is nothing but how do you approach the solution for the problem? What are your approaches? So each and everything is like a apt skill or an apt requirement for intelligence. So it is nothing but whenever people are showing more and more signs of completing a task, or doing things differently, or doing things in a more efficient way, or doing it in a very fast pace of time. So all these things can be termed as intelligence. So while comparing people, you call people as more intelligent and less intelligent because they are showing these set of qualities. So all these qualities are required for a person to be called as intelligent, or any machine or any computer to be called as intelligent. So that is the term called intelligence. But what is artificial intelligence? So what is artificial intelligence is very important to understand right now. So what is artificial intelligence, or how intelligence comes from artificial intelligence, very important to understand. So whenever we are thinking of artificial intelligence, the first thing that we come into picture is artificial. So what is the thing called artificial? So anything that is being man-made, or which is created by humans, which is not naturally available in nature, is called as artificial. So the thing is, most of the natural beings in this world are intelligent because they are adapting to new situations. They are learning from the things. Even an ant to a human. So each and every living being is intelligent in its own way. But whenever we think of intelligence, we think of human beings, because human beings are considered as one of the most intelligent people in this whole universe. So they are considered as like the living beings which can show the maximum amount of intelligence can be shown by human, and humans can adapt to any situations that they are given into. So they can think in an emotional aspect. So all those things are available to humans. So whenever we consider the term called intelligence, we'll be referring to human intelligence, not any other animal intelligence. So what is artificial intelligence is, whenever an artificial machine, that is a man-made machine or a computer or any kind of device, is replicating human behavior. Since humans are considered the most intelligent people, so if you replicate humans, so you are showing the behavior or the aspect of artificial intelligence. So that is how like the term called artificial intelligence was developed. So if artificial systems are replicating human behavior and completing the task or completing any given amount of work with intelligence, that is with more efficiency in a lesser duration of time, applying logic, self-awareness and all those important qualities of intelligence. So that is how artificial intelligence is evolved. So the basic definition that I could tell you is artificial intelligence is nothing but whenever a machine or a computer system mimics human behavior. Whenever it replicates human behavior, it is showing artificial intelligence. So this is one of the aspects that is like very important to understand, that needs to be kept into picture while understanding what is artificial intelligence. So machine showing or machine replicating human behavior. So that is artificial intelligence. So actual definition of AI, if you go into the picture of actual definition of AI, so the ability of machines or computer systems to perform tasks normally requiring human intelligence, such as translating between languages, visual perceptions, decision making. The ability to solve problems in uncertain environment is continuously improving as it learns from the experiences and the data it collects and processes. So this is a very important definition. So what machines can do is nothing but whenever a machine is said to be artificial intelligent, it can do human actions. So what is tasks that require human intelligence? So tasks that require human intelligence is nothing but translation between languages. So any task where human intelligence is being used. So when you translate between different languages, when you can see objects and you can detect it as any particular kind of object, when you can make decisions, when you can make predictions, when you can calculate, all those are human intelligence aspects. So whenever you are considering human intelligence aspect, it is nothing but the tasks which can be completed using human intelligence. If the machine can use, or if the machine can perform the same task that can be performed using human intelligence, so then artificial intelligence is being evolved. So the major thing in artificial intelligence is the concept called as learning. So what is learning, or the concept called as learning, is very important in artificial intelligence. So whenever you give a definition of artificial intelligence, the thing is learning is very important. So if the system does not learn, then it is not artificial intelligence. For example, I would take an example of the computer system which has a calculator. So you can take a basic example of calculator. So even humans can add, humans can subtract, humans can divide, humans can take out the square root. So all those things even a calculator can make. But can you call a calculator as an artificial intelligence system? So that is the next question. So the problem is, to call a calculator as an artificial intelligence system, first we look at the definition. So any device or any system which can mimic the human behavior or replicate the human behavior is artificially intelligent. Yes, the calculating is replicating the human behavior of calculation, so that is one part. But the major thing is the ability to learn from the past experiences and the data that is provided. So if I am providing any new data, or if I am providing a pattern of any data, the thing is the calculator cannot understand the pattern of new data or cannot learn any new things other than doing a programmed thing, that is addition, subtraction, multiplication, division. So very important to understand, most of the devices in this world will perform or will replicate humans. But the thing is, whenever it replicates humans or whenever it mimics human behavior, it just mimicking human behavior cannot be considered as artificial intelligence, because there is no concept called as learning in them. So learning is one of the most important concepts that you need to understand while dealing with artificial intelligence. So whenever our device learns from our previous data or is able to do something with previous data and predict new results, adapts to new situations, so that is very important. So for example, coming to the calculator example, your calculator can do maximum calculation of around 10 digits to 10 digits. So that is the maximum length. So if I give something more than that, it is not able to do. But humans can do it. It is not impossible. It will take some time, but humans can calculate digits of any number, digits of any length. So those things it can do. So the thing is, there is like no learning that is happening in conventional coding machines, but in case of artificial intelligent machines, there is learning happening. So very important to understand the concept of learning. Okay, so coming to the next question that we have is computer chess game an example of artificial intelligence? Yeah, so whenever we consider the computer chess game, so the important thing is computer chess game is found in different kinds of operating systems, is found in different kinds of mobile phones, is found in different kinds of devices. So is this an example of artificial intelligence? The next question. So the thing is, whenever you play with a computer or whenever you're playing with a computer device, yes, it is mimicking human behavior. So what is the human behavior it is mimicking? It is able to play the computer chess game. So a human can play a computer chess game. So as well as a computer can play a computer chess game. So it is playing. But the thing is, can we call it as an example of artificial intelligence? So the answer is no. You can't call it an example of artificial intelligence. So any computer game for that matter, whether it may be shooting games or whether it may be arcade games or whether it may be any kind of strategy games, the major thing to understand is all those games are written with the help of a logic. So logically pre-coded games are not artificially intelligent. So they are just running on a particular kind of code which is written in the backend and working. So once you understand the whole logic behind the game, you can easily surpass the whole game and you can win continuously without losing. So that is the important part. So whenever you are thinking of any situations where you have created games, the game is not learning from you or learning anything from you. What it is doing is it has a series of steps that needs to be followed while executing the game. Only those series of steps it is following. So that is what is this artificial intelligence being not involved. So it is just a pre-coded measure that is nothing but a code is written in the backend. It is running that code. Whenever I play with that, the code will get executed and it will run. But nowhere learning process is involved. So whenever the system is not learning anything or adapting to new situations, so there is no concept of artificial intelligence being involved. It is just a normal computer pre-coded game. So that is an example of calculator also. It is just pre-coded. There is no human intelligence, artificial intelligence being involved. It is just a pre-coded logic or a pre-coded measure. Whenever you think of artificial intelligence, it must adapt, it must learn to the particular situation. So whenever you are playing very well, it must play better than you. That is how artificial intelligence is evolved. So chess game, computer games are not examples of artificial intelligence. They are just examples of pre-coded games or pre-coded applications. So then the next thing that we need to understand is, why do we need artificial intelligence, or is there okay, so we have defined the artificial intelligence term and we have understood what is artificial intelligence. But the thing is, we already have a lot of machines that are mimicking human behavior. But why should the machines learn, or why should the machines do anything that needs to adapt to new situations, or is there any necessity for the machines to exhibit artificial intelligence is the question. So the important thing is, machines are able to perform monotonous tasks. So what is monotonous tasks? Tasks which are repeated continuously, hour after hour, day after day, year after year, so that they are continuously running. So monotonous tasks are performed by machines with more efficiency and reliability. So machines can perform monotonous tasks very easily. So, and they can even perform it day in and day out without making any error. So that is there. So whenever you're doing using a calculator and you're calculating something, so how 1,000 times or 10,000 times or 1,000,000 times if you calculate also, you will get the same result and you will get the accurate result itself. So calculators won't make a mistake, but humans will do mistakes. So that is why humans are ill suited to perform monotonous tasks. So humans can do tasks which can involve thinking, which can involve problem solving, but the same kind of task, when it is given to humans, there you're just wasting human resources. So that is very important. So machines are always used for performing monotonous tasks. But the problem is, whenever we have complex problems, conventional computers have issues of adapting or learning from new situations. So what is this complex problem? So whenever I told you about the calculator, so the maximum range of the calculator is around 10 or 11 or 15 digits. That is the max. So whenever you have things or calculations which are more than 15 digits, 20 digits or infinite number of digits, so the thing is, you have issues adapting to those situations. So if the system is artificially intelligent, so then these situations can be tackled. So it can learn from the pattern. So then it can start to use some things which are different from the normal calculating steps and adapt to the situations of the new data and perform calculations. So that is how these complex problems are solved. But conventional machines or conventional computers cannot handle or cannot adapt to new situations. So whatever the code is being written, it will execute that code. If there is any new error that is arising due to the thing, so it will display an error, but it will not solve the problem. That is why artificial intelligence is required. So what is artificial intelligence trying to do is, it is improving the machine behavior for tackling the new situations. So what is machine behavior? So whenever you are dealing with machines, so it is improving how machines act, or how machines will take in a problem, will adapt to a situation, will come to the conclusion. So all these things are performed by our machines. So very important thing is artificial intelligence. Yes, it is needed. Why? Because machines, when are placed in the normal environment, will perform fantastically. They'll give their respective result. But whenever they're given some situations, whenever they are given some data, or whenever they are given some process which they are not used to or which they are not programmed to, then there is a problem of adapting to those problems. So that is solved with the help of artificial intelligence, which will continuously learn with the data that is coming in and also take in some actions which are required for that newly learned data. So that is how AI is trying to improve each and everything that is happening around us. So a practical use case of AI. So I would like to take this simple and beautiful example of dealing with practical use case of AI. So what we are trying to see here is pretty simple. So we have a traffic police or a traffic cop who is trying to find the violators, or trying to find the people who have violated in the traffic offenses. So then we have an artificial intelligence system which is detecting the number of vehicles that are performing the traffic violations, detecting their number plate, and automatically sending the number plate address, that is the violation, to the number plate, that is sending the particular violation to the number plate's address, that is the owner. So it is sending all the information too. So this is one artificial intelligence system, but the human is also trying to do. So think of a practical scenario. A traffic police cannot stand in a signal or stand on the road for 24 hours a day. He has his time duration, that is from either 9:30 a.m. in the morning to 4:30 p.m. in the evening. So the maximum duration is 10 or 12 hours. So any violations that are happening that away from his time zone, that is not being considered, so that are being left out. And one more thing is, whenever you consider a normal human being, at a time he can catch 2 people or 3 people or 3 or 4 violators at a maximum stretch. So if 100 vehicles are coming towards him, and all the vehicles have some traffic violation that has been committed, so he can't catch all those 100 vehicles. So the thing is, humans cannot do those things which are monotonous and which are time consuming. So humans are ill suited to do those things. So if you give it to an artificial intelligence system, so it can do it 24 hours a day. Yes, it will do 24 hours a day. It will do monotonous tasks. It will be doing repeatedly, and there is no possibility of errors that are being occurring. So there is no possibility of errors whenever you think of AI being involved. So it is 100% not 100% accurate, but the thing is, there is no human error that will be occurring in those situations. And the thing is, it can cater more and more violators, that is, it can target more and more people. It need not be only 2 or 3 people at a time. So all those things taken into picture. So that is why you need artificial intelligence. Whenever there are monotonous tasks, so it can adapt to new situations. For example, during the day, the lighting conditions will be different. So the lens, the exposure of the lens, so the way the image is being taken, so all those things are different. But in case of night, so the images are totally different. It needs to adapt to the night situations to capture the picture of the number plate. So in case of a bus, the number plate will be at a different position. In case of a 2-wheeler, the number plate will be at different position. So each and every time it is learning the positions, learning the coordinates, learning how to work. So that is why it is an artificial intelligence system, but not a computer chess game. Computer chess game is a statically pre-coded option. Here the thing is, it keeps on learning with the new examples, keeps on learning with the new data that is given. So this is a practical scenario or practical use case of artificial intelligence, where we are trying to deal with violation systems. Okay, so the next part that we are all talking about is Turing test. So what is Turing test, or how Turing test is being used in the whole concept that we'll try to understand. So Turing was a computer scientist back in late 1950s or 1960s. Okay, what Turing did was Turing started a test called as Turing test, which would be able to make the machines, or which would be able to grade the machines as intelligent or not intelligent. So if there is any particular machine, so if it passes the Turing test, so then that machine would be considered as intelligent machine. So this concept of artificial intelligence came back late in 1960s as well. But the important thing is Turing already designed a particular algorithm or designed a test which could test whether a machine is intelligent or not. So what is this Turing test is pretty simple to understand. So we have one computer, that is one computer system, then we have a human system. So then we are trying to play a game with a computers with two humans and one computer. So one person is acting as a judge, and one computer is also playing with that judge, and another human is also playing with that judge. So the major thing is all these three people are isolated and are playing it separately. So there is no mutual connection between the three people. So once the judge or interrogator is in the picture, so he tries to play a particular game with the computer as well as the human player. So if the computer plays so well, and as well as the human player, if the judge is not able to differentiate who is the computer and who is the human, so then that machine has successfully passed the Turing test and is able to tell that the machine is intelligent. So that is how Turing test is working. For example, whenever the judge or interrogator is playing with the computer, so he will try to communicate something. So he will try to play and give a certain set of commands, or ask some responses and get some ask some questions and get some responses from the computer. So similarly, when the judge or the interrogator tries to communicate with the human, so similar kinds of questions and answers will be exchanged between these two people. So but if the answers given by the computers are so similar to the human being such that the interrogator cannot identify who is the computer, who is the human, so then the computer or the machine has successfully passed the Turing test. So this Turing test will tell us whether the machine is intelligent or not. So in this game we have an interrogator. So if the interrogator would not be able to identify which is a machine and which is a human, so he will not know in prior who is human and who is machine. He'll be just trying to communicate with the both devices, that is both players, whether it is a human or a computer. Then the computer passes successfully if it can work like human. So if it can think like a human, it can perform like a human, and the person, that is the interrogator or the judge, cannot identify which is the machine or which is the human, so then it has successfully passed. So basically Turing test was done to identify whether a machine was intelligent or not. But the major thing is Turing test was designed late back in 1960s. So this test is failing to identify the modern devices as artificially intelligent or not. So this definition of artificial intelligence, that is the modern day's definition of artificial intelligence, is different. So that is why Turing test fails to identify artificial intelligent devices. Why? The reason being, today's definition of artificial intelligence is totally different, where it involves learning and adapting from previous situations, as well as giving into a model or giving into a data. So the whole thing is, whenever there are situations which involves learning or learning from the previous data, so you cannot identify or you cannot tell that Turing test is an actual test to define artificial intelligence, or test to define whether the machine is intelligent or artificially intelligent or not. Major reason is, I already told you, whenever you think of a test being conducted, that is while the interrogator tries to communicate with the computer or a human, so we can make the devices work exactly like a human. But the major thing is, they are not able to learn something. That is, normally coded computers or normally coded calculators cannot learn anything. That is why you can't predict whether it is artificially intelligent or not, even though they're mimicking human behavior. So the new definition of AI is nothing but it should learn something. So adapting to new situations is not happening. So that is why the definition of AI fails, and Turing test is not used today. It was just a simple test done in 1960s, where the whole concept of artificial intelligence came into the picture. So this is when scientists thought that like computers could overperform humans, and computers can do things which can do things better than humans as well. So this is one simple test. So it is not being used anywhere, and it is not able to detect the present artificially intelligent systems, whether they are artificial intelligent or not. So this was an old test. So then we have the concept of machine learning. So what is the concept of machine learning is very important to understand. Is it same as artificial intelligence, or is it equal to artificial intelligence, or is it quite different from artificial intelligence? We'll try to understand. So whenever we are thinking of a concept called machine learning, so one important thing to understand is machine learning is defined as the power or empowering the systems with an ability to learn. So whenever systems or whenever you have computers which are empowered with the ability to learn. So what is this empowered with the ability to learn is pretty simple. So whenever they are enabled with the ability to learn, so then we can define the whole system as, or the whole concept as machine learning. So if there is a machine which has been provided with the ability to learn, so then that machine is like called as a machine, then the whole process is called as machine learning. So machine learning is not a like machine learning is just a concept, or machine learning is an idea where computers are learning from the previous data and the present data. So that is very important. So whenever you can make a machine learn, or whenever a machine has an ability to learn, so then that concept is called as machine learning. So what is the intention of machine learning, or how is it different from artificial intelligence? We'll try to understand. So coming to the basic definition of AI, we know that artificial intelligence is nothing but mimicking human behavior. If the humans have a behavior to learn, so then obviously a machine, if it has a behavior to learn also, then the machine is also mimicking the human behavior of learning. So yes, machine learning is a part of artificial intelligence, but cannot be considered as artificial intelligence. So it is not equal to artificial intelligence, but it is a subset of artificial intelligence. Very important to understand. So the behavior of humans to learn something is nothing but the concept of artificial intelligence. But since learning is not the entire thing about artificial intelligence, it is a part of human behavior. So it is exhibiting or mimicking human behavior. So it is a part of learning. So that is why it is considered as machine learning. So what is machine learning? It is the ability of machines to learn with some, whenever the machines are provided with an ability to learn. So that is called as machine learning. So why do we need machine learning is nothing but whenever machines are able to learn something, so they can make accurate predictions. So what is the accurate predictions that they can make is pretty important to understand. Whenever I give some data, so what is the data that I give? Whenever I give a data of 20 years of blood pressure data to a computer system, so if it can accurately predict what would be my blood pressure tomorrow, having all the 20 years of previous data, then it is able to learn from the previous data and able to make predictions. So that is why you need machine learning. So the whole concept of machine learning is pretty simple. It is nothing but taking in the ability to learn from the computer systems and able to make some predictions. So what is predictions? It must be able to predict that this particular thing will happen, so this particular result will occur. So all those things are happening with the help of machine learning. So machine learning is not exactly equal to artificial intelligence. It is a part of artificial intelligence, or it is a subset of artificial intelligence. So whenever you think of machine learning concept, it is pretty simple. So whenever you have a computer system which takes in data, that is nothing but whenever it is using a lot of data to learn something. So after using the data to learn, then it is able to predict some result out of that learned data. So then you call that particular system as a machine learning concept enabled system. So machine learning is not equal to artificial intelligence. It is a subset of artificial intelligence. So understanding the whole difference between artificial intelligence and machine learning, so we will see this. So artificial intelligence is the whole bigger picture which is involved in mimicking human behavior. So whenever any system mimics human behavior, then it is considered as artificial intelligence system. So the subset of artificial intelligence is machine learning. So this machine learning involves some statistical methods. So what are statistical methods? Are nothing but some procedures or some algorithms which enables the machine to improve with experience. So what is improve with experience? Whenever you are giving data to machine, so it is learning from the data and improving its output or improving its results. So that is how machine learning is being involved. So whenever you hear machine learning, important thing is data. So data is given to the system, it is learning from the whole concept of data and able to make some predictions. So you give some data, that is blood pressure data, it is able to learn the whole pattern from the particular blood pressure data and able to make some new predictions. So making insights out of the entire data using some algorithms and doing some or giving some predictions is machine learning. So very simple to understand. So what is the concept of deep learning? Is very like a complex procedure. So we'll discuss about deep learning, but not right now. Let us not complicate things more and more. So we'll just try to understand what is deep learning. So deep learning is nothing but a subset of machine learning. So the whole concept is artificial intelligence. So under that there is a subset called machine learning. Under that we have a subset called deep learning. So what is this deep learning doing is it is a part of machine learning. So it is a procedure, or it is a method where machine learns from data, that is sure. But the thing is, it is involving a concept called as neural networks. So we'll just try to understand what is neural networks or what are artificial neural networks in the later stages. But one thing you need to keep in mind right now is they use a concept called as neural networks to enable machine learning. So deep learning is nothing but a subset of machine learning which uses neural networks to help the machine learn. So that is how it is working. So whole thing right now we have discussed, that is what is artificial intelligence, what is machine learning, and what is deep learning. So machine learning you have discussed, and what is deep learning is nothing but a part of machine learning which involves neural networks. So we'll just understand neural networks later. So what you need to consider it is a part of machine learning. So deep learning is part of machine learning which helps to make the machines learn from the data using the concept of neural networks. So that is the thing that you need to understand right now. So what is neural network? We'll try to understand it later, but this is the basic structure, or this is how the whole concept of artificial intelligence lies with you. Okay, so the next thing that we are going to try is how to make a machine learn. So we told that yes, machine is having an ability, or we are empowering the machine with the ability to learn. Since empowering the ability for the machine to learn is mimicking the human behavior, we consider it as a part of artificial intelligence. So what are we trying to do exactly with machine learning is the next question. So we are giving in data to predict some results. So what is the data that we are giving? What is the result that we are predicting? So to understand this, what we are trying to do is we are taking in a machine or a computer system. So machine can be anything. It can be a robot, it can be a computer system, it can be a processor or anything. So what we are trying to do with that machine is we are continuously giving data. So in this particular example, we are trying to give the data of cats and dogs. So we are giving images of cats, we are giving images of dogs. So that images of cats and images of dogs are being taken. So after taking in those particular kinds of images, what the machine does is it will learn from each and every image. So there are hundreds of images that are given to the machine. So each and every image, for example, it will take the image of a cat. So it will analyze what are the features of a cat image. So what is the features of a cat image? So the cat is the face of the cat is round. So there will be distinguishing factor of the eyes being small, and the whole color pattern of the cat. Then the ears will be top of their face, so that is important. So these are the kinds of features that it will extract from each and every image. So the more images that you give, the more features it is trying to extract. So after extracting the features, so then we will give the images of dogs. So what is the images of dogs that we are trying to give is, we are trying to give the images of dogs, different kinds of dogs. So it is learning from the images of the dogs that the hair color is this, the whole shape of the dog face is this. So each and every pattern it is trying to understand from the different images that we are trying to give. So very important thing is, what happens when we give data is the whole the machine or the whole computer system is getting trained. So training is a very important thing in machine learning, or a very important concept in machine learning. So it is similar to a situation when it is given to a small child. Whenever you give a small child images of cats and dogs, so you tell this is a cat, this is a cat, like giving examples stating that this is a cat. So you are able to make the child understand that this is a cat. So whenever you give an image of a dog, so you make the baby understand that it is an image of a dog. So that is how we are training the baby to understand the difference between the cat and the dog. So similarly, when I give different images to the machine, so the machine is able to understand that there is a difference between cat image and difference between dog image. So when it is able to make the pattern understanding or learning the pattern of difference between the two kinds of images, so that is what it learned. So it learned that there is a difference between these two kinds of images. So this image is like the features of this image is stored like in a particular format, and the features of the other image is stored in another format. So it is able to understand that these images are different. So it is able to learn from the images that how these two particular kinds of images are different. So then when we give testing data, so when we give a testing data of a Siberian Husky dog picture, so it is able to understand that yes, the Siberian Husky dog picture is similar to or it has more features when compared to the dog image, which has more features matching the dog image than the cat image. So that is why it belongs to the dog category. So similarly, if I give an image of a cat, so it is able to predict that yes, this cat image has features which are more like resembling more of a cat rather than a dog. So that is why it belongs to the cat category. So that is how it is forming. So the important thing is whenever you are trying to make a machine learning work or trying to train a machine, so the major thing is the whole at the end of the whole like the learning process, the machine is generating a model or machine is generating a program. So what is this program is nothing but it is a stored model or it is a compressed format data which is telling that how these different images are being generated or what is the difference between the data in which I have trained. So what is the whole difference between the cat and dog images, or what is the whole difference between the different sets of images that I have given. So then when I give a testing data, that is nothing but whenever I give a new data, it is able to learn from my previous data that yes, this is an image of a dog because it is resembling the features of a dog. Yes, this belongs to a dog category. So this belongs to a cat category. So right now we have just given images of cats and dogs to the whole machine or a computer. So then it is able to generate a pattern that how these two things are different, or whenever a new picture is given, how to detect any of the particular two things in the picture that is given. So at the end of the machine learning process, always a program is generated. So that is how it is different from a conventional programming model. In a conventional programming model, we don't generate a program. So what is a program? We'll try to understand, or what program is being generated. But the thing that you need to understand is whenever a data is given to the machine, it is trying to learn the pattern, or it is trying to learn the feature differences or the feature similarities between the different data that we have given and trying to make some predictions with the testing data. So it is similar to a artificial intelligence concept, because humans, that is even a small baby, can differentiate between a cat and dog. If a machine can do it, so then it is able to mimic human behavior. But where is artificial intelligence being shown? With more and more data being provided. So if 100 images of cats are given, 100 images of dogs are given, then it will predict with more accuracy. So if 1000 images are given and 1000 images of cats and dogs are given, more and more accuracy it is able to predict. So that is how, with more and more data being given for a machine or a computer to learn, the accuracy becomes higher. So what is this program being generated? We will understand right now. So in traditional programming, what happens is we have the data, we have the program. So whenever we give it to a computer, it is giving us the output. So what is the data or what is the program that it has given, we'll understand. So you consider a situation where you are going to a computer laboratory. So you go and sit in your computer laboratory, you type in a program. So after typing a program, you will give a data. So what is the important thing that you need to get in the end? The output. So if you're not getting the output, either your data is in another bad format or your program is wrong. That is the case with traditional programming. But what happens in machine learning is you are giving the data and you are giving the output, but the computer is generating a program. So what is the data and what is the output? So here, so this is the data, all the different images of cats and dogs or my data that is being given, but it is able to, and we are also giving the output. So what is the output? It should predict my data either as a dog or it as a cat. So that is the output that is required for me. So if I give my data and if I give my output, it should generate a program. So what is this program? It is not literally a computer C or C++ program which has print and conditional statements in it. It is nothing but a model. So what is a model? Is nothing but it is telling the correlation or the difference between these two sets of images. So whenever we are trying to load or whenever we are trying to learn, it is telling us what is the difference between a particular set of images. All these feature differences are stored in a compressed format that is called as a program. So we call a program as a model also. So this model involves the difference or the data that is being learnt. So that is what you will get. So what is the advantage of loading a model, or why do we need a model to be loaded is very important. So whenever I train one machine with different kinds of data, so I train that machine to predict some data, it will give me a model. So what is this model having? How these two data are different or how these two data are similar. So all those feature differences and feature similarities it is trying to make out. So after making these feature similarities and feature differences, what it is trying to do is storing in a compressed format. So that is why it formed a model. So this model or program, once it is being generated, it can be used by other machines to predict. So no need for the other machines to learn the whole image data. It can use this correlation between different images, that is how these images are different. So it can use this whole model or a program in the future different computers or in different systems without actually learning like explicitly or without learning. So it can just able to predict results from the learning that is happening from the previous computer. So it is an example of where your teacher learns from a particular textbook or a particular book, but comes and tells you a thing in a condensed way. So she gives you a notes. So that is nothing but this program. Once you have the notes with you, you can answer the questions that is given in the test. You don't need to read the whole textbook as a whole. So that is how this program or model is being helpful. So that thing you need to understand. Correlate the concepts, you will be able to understand it better. So your teacher, once she learns from a reference book or a textbook, so she is able to like come to the conclusion that this is the particular topic, that is how I need to explain. So when you are given this condensed form, that is the notes, that is nothing but a program or model in a machine learning model, you can use it in other systems to just able to predict the data. What is the data that I need to predict? I don't need to undergo a full training procedure involving different kinds of images. So that is how a machine learning model is being evolved or being formed. So then we have a concept of what is algorithm. So whenever we are trying to use algorithms are being used in different parts of the world, even from millions of years, to do any particular set of tasks. So just going to your college is also an algorithm which involves a series of steps. So what is an algorithm? Algorithm is nothing but a set of rules that needs to be followed while solving a problem or while calculating something. So whenever we are trying to solve a problem or calculate something, we come up with the concept of algorithm. So what is this algorithm? Is nothing but a set of rules or a procedure. So whenever you want to do something, there will be always a set of rules or procedures that needs to be followed. So if you don't follow the set of rules or procedures, what happens is you will not be able to arrive at the result in a systematic manner. So to arrive at a result at a systematic manner or in a systematic way, so very important thing is you must be able to apply it in the form of algorithm. So there are always certain steps that needs to be followed. Why algorithms are being used? Why can't I solve a problem without using an algorithm? Is once you get stuck or once you have an error in a particular step, you don't know which step are you in and how the error needs to be solved. So if you have an algorithm that is being written in a systematic manner, you can always go back to the previous step and see what is being done wrong so that I can solve this entire process. So systematic approach to any kind of the rules or regulations or systematic approach to any kind of problem solving is very important when you consider the concept of algorithms. So how to build an algorithm, or if you want to build your own algorithm, three important things are there. What are the three important things that you need to consider is, One is historical data sets. So what is historical data sets? It's similar to the thing that I told you. Whenever you have a lot of previous data, so whenever you have lot of data sets, so data set is nothing but collection of data is called as data set. Whenever you have a large amount of data sets that is being available, so then you consider those data sets as a part of your algorithm. Whenever you are creating a new series of steps, obviously you must have experience of solving those particular problem in many ways, right? So whenever you are trying to create an algorithm for calculating an LCM of a number, you must have solved how to calculate an LCM of a number for hundreds of numbers. So then only you will know the exact steps. So that is why you need a historical data set. A method of production. So what is a method of production? Method of production is nothing but how actually the steps are being involved. So what is the mathematical correlation between the steps, or how each and every step is moving into the next step. So what is the whole procedure that is being involved is a method of production. Then description of success. So this is very important to understand. So what is description of success? So whenever you are trying to build an algorithm, so how is success defined? So if I consider a algorithm of calculating the LCM, so whenever I calculate the LCM of the different numbers, so if I'm able to calculate the LCM successfully, so then that is description of success. So description of success will tell me what is the end point of this algorithm. So how will my algorithm end, or how would I define whether the algorithm has completed all the steps properly or not? That is what is success. So description of success is nothing but at the end, what am I getting? So that is the whole concept of description of success. So whenever I want to build an algorithm, three important things. One is I should have solved it using hundreds of data, so that is nothing but I should have historical data sets. Then I should have a method of production. So what are all the steps that I have, whether it is mathematical steps or logical steps, what are the steps that I am following? Then I will have the last part, that is description of success. So how do I describe that my algorithm has executed successfully or got my results properly? So this is the thing that is involved in a concept of algorithms. So why we discussed about algorithms, I will tell you, but let us go through a simple example of what is an algorithm structure. So we have a simple use case of a lamp not working. So we have a simple use case of lamp not working. We'll just see a method of how to repair that lamp not working with the help of simple algorithm structure. So if the lamp is not working, so we have a next block, that is whether the lamp is plugged in or not. So we have a condition which is trying to get checked. So what is the condition? Lamp is not working is the first important block. So after lamp is not working, we'll move on to the next condition and check whether the lamp is plugged in or not. So what is plugged in? Whether the lamp has power connection or not. So if the lamp is not connected to any kind of power source, then obviously you need to plug in the lamp. So if the lamp is plugged in also, so what is the next step? Even if the lamp is plugged in, the lamp is not lighting up. So then what you will do is you will move on to the next step and check whether the lamp is burned or not. So if the lamp is burnt, yes, the bulb has a problem, so replace the bulb. But still, if the lamp is also not burnt, so how would the entire thing cause a problem? Is because of the lamp socket. So please change the lamp socket. That is how it will work. So this entire thing is an example of algorithm involving different blocks, and it is trying to move into different steps whenever there are errors or whenever there are diversions that is happening in the whole steps of the algorithm. So whenever the conditions are not getting satisfied, it is trying to move into different sets of consolidated as well as systematic procedures while checking out anything. Here you can't make anything wrong. Even if you commit a mistake, you can always go back and check what is my previous step and try to rectify your error. So that is why you need series of steps when involving machine learning or while doing machine learning concepts. So the thing that we need to consider next is what are the different types of machine learning that is being involved. So what are the types of machine learning that we'll try to consider now is, so types of machine learning is nothing but, it is not the different methods how a machine learns, it is nothing but different algorithms that the machine uses to learn. What are all the different algorithms are nothing but series of mathematical steps that the machine will use to learn. So what are all the different algorithms that the machine will use to learn that we'll try to understand. So the first one is called as supervised learning, the second one is called as unsupervised learning algorithms, and the third one is called as reinforcement learning algorithms. So we'll try to see each one of them in depth. So basically, to understand, we have different types of machine learning algorithms. So machine learning is nothing but the concept in which machine is learning from some kind of data and able to make some predictions. So that is machine learning. So then what you are trying to do is it has different algorithms. So different set of mathematical steps and procedures to learn. So types of machine learning algorithms, we consider them as supervised, unsupervised and reinforcement learning algorithms. So algorithm is nothing but a series of mathematical steps that is being involved to solve a problem. So either you can call it as different types of machine learning or different types of machine learning algorithms, one and the same. So not a problem. So starting with supervised learning. So first we'll understand the term called supervised learning. So what is a supervised learning algorithm? Supervised learning algorithm is nothing but it consists of a target variable or an outcome variable which is to be predicted from a given set of independent variables. So very simple to understand, you have a target variable. You have a target variable that needs to be predicted from the given set of independent variables. So best way to understand this is y is equal to mx plus c is the best example. What is y is equal to mx plus c? You have your y, that is your dependent variable, and you have your x, that is your independent variable. If y needs to be predicted from x, what are you trying to do here? If y needs to be predicted from x, what you are trying to do? You are trying to match between these two. That is, you are trying to find out the value of y by using the value of x. So that is what is the basic concept of supervised learning. To understand it in a more simple way, we'll try to understand with the help of a visual example. So what we are trying to give in here is an input. So this input contains apples, mangoes and bananas. So this input is a mixture of apples, mangoes and bananas. But at the output, I have three things. So three things is apple, mango and banana. So the thing with supervised learning is you already know what is the output that you want. So whatever input that you have needs to be sorted out only into these three outputs: apple, banana and mango. So if the thing is, it is already supervised, you know what is the result that you want. And the output predictions must be only three, that is apple, mango and banana. So you have hundreds of raw data that you have. What you are trying to do is, since you know already the output is apple, mango and banana, what you do is you try to compare. So if I have an apple, so I compare with the output, whether it is similar to banana, whether it is similar to mango or whether it is similar to an apple. So then I will predict, yes, this output belongs to the category of apple. So what we do in supervised learning is we create categories of outputs. So category 1 is apple, category 2 is banana, category 3 is mango. So whatever data that we given, we try to categorize all the data that we are getting into these three only. So we can't have any output other than these three. So that is why it is called supervised. So the output is supervised. The output is fixed. The output cannot be anything new. It can be only the things that we have fixed in our algorithm. So that is what is called supervised learning. So for another example, if we consider, so I will have an example of green apple as an input. So if I have an example of green apple as an input, so I will just check which is similar to what. So green apple is an input, I will check whether it is similar to mango, no. Whether it is similar to banana, no. Whether it is similar to apple, sort of similar, because the color is different because it is green in color, but the shape and all is same. So I would put it in the place of an apple. So whatever data that you have, whether it is the same data or different data, you must be able to classify the data into the same output part. So that is why that is how you have a supervised learning algorithm. So the meaning of supervised is nothing but telling that you already know what is the output, you are just taking in data and you are sorting out and you are putting the particular data which you have an input in those outputs. So this is the example, or this is how you understand supervised learning. So whenever you think of supervised learning, just think of an example that output is already there. You are just trying to take in new data and trying to put it into those predefined outputs. So that is the basic concept. So another way to understand the concept of supervised learning is pretty simple. So one way to understand this is, I will tell you a normal situation, or a situation where you can understand it very much easily. So you have a teacher. So there is a situation where the internals is coming very quickly. So the teacher could not complete any portions. So what the teacher did was, there will be three topics that the teacher told to the student that there will be three topics. Out of these three topics only, the entire question paper will be framed. So the teacher told that yes, this internals will have only 3 topics. Out of these 3 topics only, the entire questions will be framed. So these 3 topics are nothing but the output. So these 3 topics will form the output. So the teacher told that these 3 are the topics that will be asked for the exam. So whatever questions that came into the exam or whatever questions that came into the question paper, the student must either classify them into topic 1, topic 2 or topic 3. So if question 1 came, the student must either classify it or either think that okay, this question belongs to this topic, so I need to answer from topic 1. So this question belongs to this topic, so I need to answer from this topic. So the main thing is the output is already fixed. You know that the exam, or you know that the answer is in topic 1, topic 2 or topic 3, but you need to correlate the questions with the answer. So which question is are targeting, or which question is being asked about topic 1, which question is being asked about topic 2, which question is being asked about topic 3. So the thing about supervised learning is your teacher is already supervised and told that these are the only questions, or these are the only topics that will be asked in the exam. So the questions that you need to map. So you as a student, you as a machine who wants to learn will map all those questions into those particular topics, stating that since it is supervised, so teacher is already supervised, I need to mark it into these topics. So this question is relating to this topic, so I need to answer from topic 1. So the other question is belonging to or is similar, is relating to topic 2. So that question is asked about topic 2, I need to answer from topic 2. So this entire concept is the simplified form of supervised learning. So supervised learning, output is already given. You just need to get the data, that is the input data, and put it in or correlate to the different outputs that have already been defined. So this is the concept of supervised learning. So then we have a concept of unsupervised learning. So what is this unsupervised learning is very simple to understand. In case of supervised learning, what we do is we have a target outcome or a fixed outcome that is there at the end. That is nothing but we know what is the output that we want to have. But in case of unsupervised learning, we don't have any target or we don't have any outcome that needs to come at the end of the picture. So all the thing that we need to do is pretty simple. So all the thing that we need to do is we need to target the variables and try to form the correlation between the data. So what is finding the target variables and trying to form a correlation is simple. So whenever you think of unsupervised learning, what we are trying to do is we don't have any fixed output. We are not telling the output should be apple, mango or banana. So what we are trying to do is with the input data, we are trying to form clusters. So how you can understand unsupervised learning is if you have a basket of fruits. So consider the basket of fruit is having bananas, apples and mangoes. So how unsupervised learning works is we are not telling that the fruits at the end, that is the output must be apple, mango and banana. But what we do is we compare the data with each and every other data. So when we compare apple with each and every other like the fruit or the bunch of fruits in our whole data set, what we are trying to do is we are trying to see whether the next data is similar or dissimilar to my data. So if I start to compare an apple with a mango, banana and another apple, so I will see what is the difference between another banana and a mango with the apple. So if I find similar kind of data, that is nothing but apples, so I will group them into one part and I will separate myself from the rest of the crowd. So it is the simple concept of sorting. So whenever I have data which is similar to my kind of data, I will sort myself out. So whenever there are mangoes, bananas and apples, so each and every data will try to find out similarities or differences between the each and every other data it has. So then it will form into separate groups called as clusters. So when it forms into separate groups called as clusters, the output was not defined earlier. There was no output that was defined in earlier times. Only thing that was being told was, yes, we have a lot of data that is given to you. You try to find out the insights from the data. What is similar, what is not similar, and how do I group the data. So one similar situation I can tell you is whenever you have people from different schools gathering in a ground, what people tend to do or what students tend to do is they'll start like communicating with the students of their own school and try to make a group. So that is what they do. So groups of different college or groups of different students, so they try to group themselves from the other people so that they are able to make a cluster, or they are able to differentiate themselves from the other people. So how would you do the first differentiation, whether this person belongs to my school or other school? The first differentiation is the uniform. So uniform will tell us whether this person is belonging to my school or another person's school. So whenever you see people of the same uniform, you think that yes, they belong to my school, and you start communicating with each other or try to form a group that is called as cluster 1. So similarly, with other schools, the same thing is happening. So there is no target or there is no output that is already been defined. Using the insights from the data which we already have, we are trying to form groups or clusters. So for example, we have this small data where we have patches or circles of green, red and black. So we have 3 patches, that is nothing but green, red, black and blue. So what we are trying to do from this data is, we are trying to find out similarities. So what are all the green colored patches that is available, that is forming one set of data. What are all the red color spots or data that is having is it will compare with each and every data that is other than that particular data. It will compare with all the other data. So it is trying to find out which data is similar to the other kind of data. Then it is trying to form a cluster. So at the end of the clustering, so we have just this data given, no other thing is being specified. At the end of this particular unsupervised learning, what is happening is, groups of similar kinds of data form clusters, that is nothing but red spots form the clusters and we have an output here. Black spots form the cluster here and we have an output. Blue spots also form the cluster and we have output. Similarly green. So it is nothing but comparing the data between similar kinds and creating the similarities and differences between the data that is being available to make differentiation. So there is no classification that is told earlier. Out of the own comparison between different data, it is able to make different classifications. So that is the example of unsupervised learning. So the next example of unsupervised learning that I would take in is similar to your question paper. So instead of the supervised learning where the teacher already gave out topics, that these are the 3 topics in which all my questions will be coming in. So what I would do is, I would just patch up these questions or just read these questions and think that okay, this question will belong to topic 1, this question is asked about topic 2, that I was doing. But in case of unsupervised learning, there is no such thing as topics being told by the teacher. No one is supervising me. So what I have is, I have a whole syllabus that I need to study for the exam. I studied the whole syllabus. So whenever I have questions coming in my question paper, what I do is I see the questions and then I am able to make a conclusion that yes, these questions are belonging to module 1, these questions are belonging to module 2, these questions are belonging to module 3. So how am I able to make the differentiation? Based on the similarities or differences between the data that I have. So I will read the whole syllabus. So after reading the whole syllabus, I am able to make, that is nothing but I am able to make conclusion that these are the questions that will belong to these particular kinds of topics. So in the case of supervised learning, I would have the topics. What I would need to do is I would just read the question and think this will belong to topic 1 and this will belong to topic 2. What I will do now is I will see the questions. So I will understand the questions. I will tell that yes, these are the questions that are belonging to this particular topic because these questions are related to this particular topic. So these are all the questions that are coming from module 1. These are all the questions that are coming from module 2. So that is what I will be doing. I won't have any preset of output, that is nothing but preset of topics from which I will be answering question. From the whole syllabus, I will be trying to make in clusters or differentiation stating that these questions are targeted to topic 1, these questions are targeted to topic 2. So that is how an unsupervised learning works. So there is no topics that are being told or there are no distinguished outputs that are there. So out of the differences and similarities between the data, we are able to make the classification. So that is what is unsupervised learning. Okay, so after unsupervised learning, we have a concept called as reinforcement learning. So what is this reinforcement learning or how is this working? We'll try to understand. So one thing about reinforcement learning is based on a trial and error method. So whenever a machine is exposed to an environment where it trains itself continuously using a trial and error method. So what is a machine being exposed to environment and learning from trial and error method is, pretty easy to understand. So whenever a machine is placed in an environment and it is learning from trial and error method, and the machine learns from past experiences and tries to get the knowledge, that is nothing but tries to get the knowledge to make accurate decisions. So what we are trying to do here is, it is a simple explanation where a machine will learn from each and every new iteration or a new step. Whenever a machine is exposed to an environment, each and everything or each and every decision or each and every step the machine takes, it is able to go through a set of trial and errors. So whether machine wants to achieve something or machine wants to do something, it is trying to do some trial and error methodologies and trial and error steps until and unless it reaches its particular destination. So this uses the concept of past experience, or this uses the concept of trial and error to go to or to arrive at the particular decision. So the best example that I can give is about a rat. So when the rat is placed in a maze and it needs to go to the destination where it has a piece of cheese, so the rat will take a particular path, then it will find a dead end in the maze. So whenever it finds out a dead end in the maze, so it is considered as an observation. So it is not the perfect path to go to my destination. So that is my observation, and it will come back to the original place. Again, it will try to find another path to reach its destination. So if it is not able to reach the destination in the other path also, so then it will eliminate the two paths also. Then it will try to find out for the third path. So the basic step about reinforcement learning is the method of elimination. So what is the method of elimination is, whenever you are trying to learn something, always you cannot arrive at the result at the first step. So if you arrive at the result at the first step, it is well and good. But if you are not able to arrive at the result at the first step, what you will try to do is pretty simple. You will do a lot of number of trials and errors until you reach the particular destination. So if you are not able to reach the destination in that particular step, you will consider that step as an observation and you will eliminate that possible step. So similarly, the rat will eliminate the possibilities one by one. So if one route is closed, it will eliminate that. In the next step, it will not take the same route. It will take another route. So if it is trying to take the same route, obviously it knows that it is not possible to go to the destination in the same route. So it will try to find out other routes. So it will do the same thing, that is nothing but process of elimination, until and unless it will arrive at the destination. So what is the destination? The reward, that is arriving at the piece of cake. So arriving at the piece of cheesecake, so that is the destination. Until and unless it arrives at the destination, it keeps on learning. So how it is learning? So this step is not possible. So this is a bad experience. So this is not good. So next it will try a new thing. So this is also not good. So this is also not the correct step that I need to take. So using trial and errors, it is able to make decisions and get to the reward. That is called as reinforcement learning. So reinforcement learning, you can straight away blindly think it as a trial and error method, where you will be trying out new and new methods until you arrive at the result. But the old methods will not be tried once again. If the method is failing at once, the old method will not be tried. New methods will be tried to reach the destination. So that is what is your reinforcement learning. So very simple and easy concept to understand. So then we will have to understand the difference between supervised and unsupervised learning. So what do we understand by the difference between supervised and unsupervised learning is, supervised learning will have fixed boundaries or fixed outcomes. So in case of supervised learning, you are predicting the fruit as apple, mango or banana. So the outcomes are already fixed. What you need to do is, you need to draw a boundary between the data and you need to tell that this is different from that and that is different from this, and try to put in those boxes. So very simple. You have two data, one is X and one is 0. Whatever data comes in to the picture, even if it is a plus, you need to either place it in X or either place it in a 0. You can't make new data outcomes. So if there are 3 fruits that needs to be predicted, any different fruit that you get also, you need to compare it and put it within the 3 fruits only. You can't make a new data and try to put in that. So that is the whole thing when it comes into supervised learning. But when it comes into unsupervised learning, there is no fixed data output that is there. What you are trying to do is pretty simple. You are trying to find out the differences and similarities between the whole data set that is given to you. So using the whole data that is given to you, you are trying to make out which is similar, which is dissimilar. So similar kinds of items you are gathering and making it in the form of clusters. So that is what you are doing with unsupervised. So unsupervised, no fixed output. Based on similarity, dissimilarity, you are trying to fix out what is the output. Supervised, there is already a fixed output. So based whatever input that you are getting, you are trying to either fix it as output 1, output 2, output 3, or categorizing based upon the output that has already been fixed. So whatever data that is given, even if it is not similar, you should be able to put it in the two different categories. So that is what is happening in supervised learning. So the whole concept of machine learning can be understood as this. So whether we are doing a supervised or unsupervised learning principle, so whether we are following an unsupervised algorithm or a supervised learning algorithm, what we are trying to do is we are trying to extract features. So what is feature extraction is very important concept in the form of machine learning. So what is feature extraction is? Feature extraction is a method which involves removing out the needed data and putting in only the needed data and removing out the unwanted data. Whenever you consider a data, there will be a lot of wanted and unwanted data that is being involved. So if I want to categorize some data, so I will remove out the waste data. So I will have a lot of waste data that will be there. I will remove the waste data and take in only data that I need for the example, and I will try to put it in a machine learning algorithm. So what is my machine learning algorithm doing? Either it is grouping it into objects, or it is classifying, or it is predicting my data. So after predicting, that is my result. So that is how the whole machine learning works. So whenever you have data, you give it to a feature extraction model where it will take out the unrequired features. So best example of feature extraction is, so I told you about the blood pressure data, but the data will not only contain blood pressure, it will contain person's age, person's name, person's address, person's phone number. So person's address and phone number is not required for calculating the blood pressure. We just need the blood pressure data. So that is how features, only important features are extracted and unimportant features are left out. After that, it is given to a machine learning algorithm. So what kinds of machine learning algorithms are there? Either supervised, unsupervised, or reinforcement learning algorithms. After giving it to that, it is able to make some predictions. So what is the prediction? Either it is trying to predict what will be my future value, or it is gathering my similar kinds of blood pressures into one cluster, or it is classifying my blood pressure as good blood pressure or bad blood pressure, that is nothing but safe or unsafe blood pressure. So these are all the things that we can do with machine learning. So this is how the whole step of machine learning is. So then we will go on to the concept called as regression. So another important concept in machine learning is regression. So what is regression, or what is, there are two important concepts to learn, what regression and classification. So if we can understand what is regression and what is classification, we will be able to make huge differences, or we will be able to learn some huge statistics with this data, and we can arrive at some results. So what is regression is pretty simple to understand. Regression is nothing but a set of statistical processes that is estimating the relationship between your dependent and not dependent variable. So again, regression, the best example for regression is the linear regression. So what is happening in the regression is it is able to plot the difference between your dependable variables as well as independent variables. So whenever I have y and x, so if I draw a plot of y versus x, so that is called as regression. As simple as that. So whenever I have an equation that is y is equal to 3x square plus 4x plus 5. So if I am able to plot the relationship, so what is the relationship between my y and x? So then I am able to trying to establish the relationship between my y and x. So that is why the concept of regression came into picture. So regression is very simple. So you have done regression in your past, that is in your physics or mathematical classes, where you had linear expressions or quadratic expressions or hyperbolic expressions. What you did was, if x is equal to 0, what would be value of y? So how will you get that? You put it in the equation. So what is the equation? Y is equal to 3x square plus 4x plus 5. If x is equal, so if x is equal to this, what will be value of y? Since x is like independent variable, so for different values of x, you will get different values of y. So after getting different x and y values, you try to plot it in the graph. So after plotting it in the graph, you will see which is the line that passes through the most of the points of the particular graph, and you would draw a particular graph line. So that is how regression works. So what is regression? A simple concept where any expression, whether it is linear, quadratic, hyperbolic or any expression, you are trying to find out the relationship between your dependent variables as well as your independent variables. So the line can be linear where the relationship is a straight line. The line can be non-linear where the relationship is not straight line, it is in the form of a curve. So the best example of regression is simple. So I have one apple which costs 40 rupees. I have 3 apples which cost 120 rupees. I would like to find the price for 10 apples. So very simple. Y is equal to, we have our, that is nothing but y is equal to 40x. So what is y? Is nothing but the cost of apple is nothing but y. Y is equal to 40 into x. So that is the whole expression that I would get. As well as another expression I will get 3y is equal to 120x. So y is equal to 40x again. So what I am trying to do is, if one apple costs 40 rupees, 3 apples cost 120 rupees, what is the price of 10 apples? So simple thing how I would do this with the help of regression is, I would draw a graph that is nothing but 1 apple 40, 3 apples 120. So I would draw points on the graph. Then I would draw a straight line which will pass through all the important points in my graph. So if I want to get the price for 10 apples, I need not calculate again. So if I just try to overlap or try to extrapolate the line for 10, that is nothing but on the graph line, if I try to find out the x and y intercept, that is nothing but I have the x intercept that is 10. What would be the y intercept? That is 400. So that is why the cost of my apple is 400. So that is how regression works. So regression is nothing but finding out the relationship between the different kinds of variables, that is nothing but independent and non-independent variable. So what kind of problems will this regression helps in? So regression is helpful in problem solving or predictions or in machine learning problems where something or prediction of future values is being involved. So what is prediction of future values? If my house costs, that is nothing but 3 lakh rupees in this particular time. So if it costs 2 lakh rupees in 1990, if it costs 3 lakh rupees in 2000, it costs 70 lakh rupees in 2020. What would be its cost in 2025? So it is nothing but establishing my relationship between my previous values of x and y, then predicting it for a future values of x and y. Not only future, you can predict it even for past. So in 1940, what would be the price of my house if the prices of my house in these years are this? So it is nothing but relationship between y and x. So then you are trying to predict some result. What would be my salary? That is also a regression problem. What would be that is nothing but price of the house in so and so years. That is my regression. If my 2 internal marks are this, what would be my 3rd internal marks? Or if my CGPA of all these semesters is this, what would be my CGPA in my next semester? So all these are regression problems. Why regression problems? You are having data, that is nothing but you are having previous x and y data. With the help of previous x and y data, you are trying to predict new y data. With the help of like the present x data, we are trying to predict the y data. So that is why it is a regression problem. Whenever you think of regression, always think of a problem where you have y and x. You are trying to find out the relationship between y and x. So this Apple example is the best example of the regression problem. So then we have an example, or then we have a concept called as classification. So what is classification? You already saw in supervised learning about the concept of classification. The outcome is fixed. So the outcome is categorized. So it is nothing but a process of categorization where different objects or different ideas are categorized and they are differentiated and understood. So if I want to categorize my different vegetables, so either I would like categorize my vegetable, if I have different vegetables in a basket, I want to categorize them. I would categorize them into tomato, bottle gourd, bitter gourd, bell peppers or brinjal. So that is nothing but a fixed category. So classification is telling me, I am drawing a boundary, I am telling that this belongs to this is this vegetable, this is that vegetable. So I am trying to classify the data into 2 groups or 3 groups basically. So that is different from regression. Regression is prediction. Whenever I want to predict what is my salary in the next year, so that is nothing but finding the relationship between past values of X and Y to predict my new values of X and Y. So here what we are trying to do is whatever data that we are having, we are trying to form a category. For example, if my age is less than 18, so I would belong to a category of minor. So if my age is greater than 18, I would belong to a category of major. So similarly, if I have different vegetables, I would try to categorize them as into different categories. So if I have 2 categories, that is nothing but if I have 2 kinds of people, that is male and female, so I would try to categorize 2 or classify them into 2 like genders, that is male and female. So classification is nothing but creating categories, putting the data into those categories. So that is what is the entire concept of classification. So this classification is very important in problems where you are trying to find out whether it is based on gender, whether the BP is low BP or high BP, whether the person has sugar or no sugar, whether the email sent by the person is spam email or a regular email, whether the person has cancer or not, whether the particular man is alive or dead. So all these situations where we have categories, we form into the category called as classification. So classification cases are different, regressions are different. So regressions, what we are trying to do from the previous data, we are trying to predict any new data. In classifications, what we are trying to do from the data that we have learnt, so we are trying to categorize the data, either it belongs to this particular class or another particular class. So that is what is called as classification. So difference between classification and regression. So here we are drawing a boundary to differentiate that X is different from these circles. So in this regression principle, what we are trying to do, we are trying to draw a best fit line that fits most of these particular circles, so that from these previous data I can predict any new data, or I can get with some examples of what is my past data also. So all these things are happening with the help of my regression as well as classification. So these two are very important while dealing with any machine learning problem. What is regression and what is classification? These two are very important. So then we need to move on with the concept called as machine learning algorithm. So in machine learning, we have 2 basic algorithms, that is nothing but supervised and unsupervised. Reinforcement will not be using them much, but reinforcement algorithms will not be using them much. The majority of the algorithms that we'll be using is either supervised or unsupervised. But the thing to consider here is, in supervised as well as unsupervised, we have 2 different parts. So supervised learning is categorized into classification and regression. So what is classification? You classify the data into different parts, that is nothing but different classes. But in case of regressions, what you are trying to do, you are trying to predict the results. What you are trying to do is, from your previous results, you are trying to predict any new decisions or any new outputs that you want to predict. So classification is classifying the data into different category. Regression is prediction of data from the previous data to get into new data. So that is what you are doing with regression. So in classification, that is in supervised learning, you have different classification algorithms. So what are the different classification algorithms that you have? Support vector machines, discriminant analysis, naive Bayes, nearest neighbors are all classification algorithms. So regression algorithms, we have linear regression, that is one of the most important. Then we have decision trees, neural network, ensemble methods, SVR, GPR. So these are all the different regression algorithms. So in clustering, we have k-means clustering, Gaussian mixture, hidden Markov model. So clustering, in unsupervised, we have only one thing, that is forming clusters. So the best example of unsupervised algorithm, I already told you, where you're just forming clusters to get an insight of the data. So these are all the different mathematical clustering algorithms. That is nothing but these are all the algorithms. In case of supervised, you have classification and regression. So very important to understand, we divided our machine learning into supervised, unsupervised and reinforcement. But supervised is divided into two concepts, that is classification and regression. So you know what is the output, that is nothing but that is classification and regression. So then you have unsupervised, where there is no output that is being given. Just with the help of the difference or similarities between the data, you are clustering the data. So this is very important to understand. Supervised will have two classes, classification and regression. Unsupervised will have only one category, that is clustering algorithms. So moving on, that is the last part, that is applications of artificial intelligence. Okay, we learned that there is machine learning being involved. We learned that there are the three different types of algorithms, learning algorithms. We learned what is classification, regression, clustering, all those examples we learned. But what can we do with the help of artificial intelligence? So first thing that we would do is deep learning and predictive analytics. So deep learning and predictive analytics is one of the most important applications of machine learning. So what is predictive analytics? So predictive analytics is nothing but predictions using the past data. So if my health condition was so and so in the particular years, what will be my health condition in the future? So that is predictive analytics in medical or healthcare. So if my marks is so and so in my previous years, what will be my marks in the future? So that is also predictive analytics. So whenever you are predicting something using the previous data, that is predictive analytics. So then we have a subdomain of artificial intelligence called as natural language processing. So what we do in this natural language processing is pretty simple. So in natural language processing, we have something called as translation. So if I can translate between different languages, that is, if I can translate between English to French, English to Hindi, English to Kannada, so any other different languages, so that is also an application of artificial intelligence. Why is it artificial intelligence? Translation, because a human can translate between different languages. Yes, a machine can also translate. But actually what is happening, it is learning from each and every translation. So it is adapting. So that is why it is translation is also a bigger part. So then we have information extraction. So what is information extraction? So whenever we have our natural language, that is nothing but whenever we have our English language, if you can extract any information from it. So whenever I speak something, if you can understand what I am speaking and if you can make sense from what I am speaking, so that is also a behavior of human. So that is also an example of artificial intelligence. So natural language processing is anything that we speak is natural language. So if you are processing the language which I am speaking, so then it is called as natural language processing. So all those applications come under natural language processing. These are all the subdomains of artificial intelligence. Machine learning is one subdomain, NLP is second subdomain. Then we have speech systems. So what is speech systems? Whether if you can convert your speech to text, if I can tell something, if you are able to convert my speech into a text format where you can write it down, so that is speech to text. So if I have written something down, if you can speak it out, so that is text to speech. So speech to text and text to speech are all examples. So the best place where you can see speech to text and text to speech is Google Assistant, where if you type something, it can read out, or where if you can answer something, it will convert, if you ask Google a question, it will convert your speech to text, then understand what you are asking and try to get result. So after getting the result, it will be in the form of text. Again, it will convert it into speech. So Google Assistant or voice assistants use this concept of speech to text and text to speech. That is also an example of artificial intelligence. Robotics. So whenever you come into robotics, you have a lot of humanoid robotics which behave like humans, which think like humans, which perform like humans. All those parts come under robotics. So my vision, so what is vision based on artificial intelligence? So you saw the picture of detection of particular objects, detection of people, detection of humans, and making lot of recognition. So if you can recognize the face, so best example is your mobile face unlock. So that is also a part of AI that is involved. What you are trying to do is it unlocks only for your face and it is not trying to unlock for other people's face. So if a human can able to recognize other people, so obviously if a machine can recognize other people, yes, it is trying to involve the concept of artificial intelligence. But when and where you are giving new images of yourself. So one day you will be clean shaved, other day you will have mustache. So all those different images it is trying to learn and it is trying to adapt itself. So that is how it is an example of artificial intelligence. It is even trying to learn new things from the examples of previous things. So these are all the applications of artificial intelligence. So I have few examples that we can understand and we can go through. So first example is about Sophia. So Sophia is like a humanoid robot that was created by Hanson Robotics. So Hanson Robotics is a Japanese based robotics company. So it is trying to create human like robots. So all the concepts that we studied, that is text to speech, speech to text, predictive analytics, computer vision where it can recognize different people, identify them, and it can do some other concepts like classification, translation, where it can speak different kinds of languages. All these things, if a particular robot can do, so even the movements, so the movements are getting adapted each and every day. Yeah, so the movements are getting adapted to each and every time, new movements, and the way it walks is also getting changed with the help of past experiences. So that is how your predictive analytics is working, as well as the new learning concept is being involved. So Sophia is an example of artificial intelligence. So it is one of the first robot to get a Saudi citizenship. You know how difficult it is to get a Saudi citizenship, but this humanoid robot was successful in getting the Saudi citizenship. Now it is a Saudi citizen. So that is how artificial intelligence is changing our world and how we are looking at the concept. So then we have an artificial intelligence concept where machine learning is being involved. So this concept is called a Spectacom Power Bat. So what is this Spectacom Power Bat is? So there is a small wireless chip that is attached to the bat. So whenever you are playing with the chip, so what is happening is each and every shot you play, so data is being generated from that bat. So it is able to analyze how well you are playing or how bad you are playing. So it is basically telling you whether you are hitting all the balls with the center of the bat, or whether you are making more edges, or whether you are able to give the correct bat speed to hit more and more number of runs. So this was developed by Microsoft in association with Anil Kumble. So Anil Kumble and Microsoft developed the concept called as Spectacom Power Bat. So the bat, which involves artificial intelligence and machine learning to analyze how we are playing each and every cricket shot, and also give out results stating that this is how you played and what will be your next score or future score. So this was a joint concept done by Microsoft with Anil Kumble. That is a good thing. So this is one of an example of AI. So then you have self-driving cars. So whenever the beautiful concept of self-driving cars into picture, so you will have the companies like Google and Tesla taking its maximum benefits. So Google and Tesla have developed self-driving cars, which involves computer vision systems which can detect vehicles in front of them to make decisions, that is nothing but take left turns, right turns, overtake a particular vehicle. So then analyze the route maps, whether the road is blocked or not. So making decisions with the help of learning. So analyze what is the size of the road. So each and everything is being analyzed. So whenever you consider a self-driving car, there are more than 10 to 15 lakh sensors that is embedded, and continuous data is coming from those sensors, and a powerful processor is able to do machine learning and make decisions and predictions for the particular car. So think how much of data and how much of processing is involved in creating the self-driving cars and enabling them to being a user friendly and a road going car. So that is there. So this car made by Google was the first car to first artificially intelligent car or self-driving car that was able to pass a driving test in USA. So this car has passed its driving test in USA, and it can operate successfully and it can operate on its own. So that is the level of AI that is being involved in developing these systems. So then at last we would come into Narayana Healthcare. So our own Narayana Healthcare, which is a Bangalore based medical healthcare facility majorly treating heart patients. So what it has done is each and every X-ray, each and every scanning is analyzed with the help of machine learning, where different images are analyzed and trying to predict results, whether the particular person is normal or whether the particular X-ray or scanned copy is normal or not. So that is what it is doing, whether a particular thing or a particular result that we are trying to predict, whether it is normal or not, it is trying to predict with the help of our systems or images using machine learning, and the number of people who come at a particular time. For example, in some seasons, the number of patients coming into the hospitals will be really high, so the number of staffs that will be required is also high. So all those predictions can be done only with the help of previous data that is made available, and it is able to successfully tell that these many people will be coming in this particular day of the week. So it is able to make those predictions, and it is also able to make the predictions based upon the scanned copies of X-rays, scanning and MRIs also. So it is able to gather pictures and make identifications such that this is a normal MRI, there is no problem with the MRI. This is an uncommon MRI, there is a problem with it. So this was the whole concept or whole basic concept of artificial intelligence that we would that we learned in our first session, so which involved a lot of things. I hope you have enjoyed the session, and we'll be successfully looking forward for our future session also. One thing that you need to do is please do revise your concepts once again. Please do learn the concepts, go back once again, learn each and every single concept, try to understand it, try to relate with more and more examples. So that is what will help you understand the whole concept of artificial intelligence. So thank you guys, and I'll be hoping you, and I will be waiting for you for the next session, and thanks a lot.